generator actually produce electricity? Now, I'm sure you'll all remember going through this subject in study of basic electricity, perhaps several years ago. But do you still remember, say, the difference between single-phase and three-phase power, or the significance of increasing or decreasing excitation, and what is meant by reactive power? We feel it will be worth our while at this point to review generation fundamentals, to lay the foundation for our discussion on generator control. This simple AC generator consists of a coil or rotor rotating in a magnetic field. The magnet has north and south poles, and its magnetic flux passes through the rotor. By convention, the lines of force or flux leave from the north pole, pass through the rotor, and then return to the south pole. So the lines of force at the south pole are set up in the opposite direction to those at the north pole. In this diagram, as we start rotation of the coil, one side passes close to the north pole and one side close to the south pole. The coil sides cut the magnetic lines of force and in doing so create a voltage in the coil. This is the well-known principle of electromagnetic induction. When a conductor cuts a magnetic field, a voltage is induced in that conductor. At 0 degrees, the coil is not cutting any magnetic flux at all, and therefore the induced voltage is 0. The value of induced voltage is maximum when the coil is in the 90-degree position, because here we have the maximum rate of cutting magnetic lines of force. The direction of induced voltage in the purple conductor is opposite to the voltage in the red conductor. The voltmeter therefore receives the sum of the two voltages. As the rotor moved from 0 degrees to 90 degrees, the voltage has increased like this. And then as the rotor moves from 90 to 180 degrees, it decreases like this. As the coil continues rotation past this 180-degree position, the conductors are cutting flux from a different pole. The red conductor is now closer to the north pole, and the purple conductor is closer to the south pole. So the voltage generated is now in the opposite, that is, negative direction. So we can see that one revolution of the coil produces one cycle of alternating voltage. It is called alternating because one half of the cycle is in the positive direction and the other half is negative.